Welcome. In this presentation, we will discuss our pilot project to make a neural machine translation engine using Microsoft Custom Translator. The engine is meant to specialize in translating cybersecurity lore from simplified Chinese to US English. So here now we begin with a brief review of our initial proposal. This pilot project will be considered successful if post-editing machine translations is 40% faster than human translation, 40% cheaper than human translation, and pass the final human evaluation. The process that we planned initially contained three parts: file preparation, 10 rounds for translation machine engine training, and human evaluation. We evaluated and compared the raw engine and the customized engine with post-editing, Google Translate with post-editing, and a full human translations. And we estimated that our final cost will be $4,991.
From this graphic, you can see that the adjustments we made to Microsoft Custom Translator formed a bell curve. In the beginning, we were unable to begin running the engine due to Custom Translator's 2 million character limit for free accounts. As we increased segmentation and shortened segments, we could add in a greater variety of documents, as evidenced by the changes made in rounds 3, 4, 5, and 6. Towards the end of the project, we made smaller, more incremental changes. Overall, our training rounds resulted in a significant improvement over Custom Translator's baseline BLEU score, which typically hovered around 28. By slowly refining and cleaning our dataset, we were able to increase the BLEU score by 21.19 points. When compared side by side, the results are stunning. The output from our trained engine is significantly better than the base Custom Translator engine. Our training resulted in a real, noticeable improvement to MT output.
We selected the Chinese cryptography law and the Chinese data security regulations as our testing data, and we used a bilingual UN corpus and the relevant Chinese regulatory files for training and tuning. After we carefully aligned the testing and the tuning data and cleaned all our training data, we did the following steps to see if our BLEU score would change. We replaced automatically aligned TMX files with perfectly aligned files. The BLEU score increased. As we replaced UN corpus segments with more relevant legal files, the BLEU score increased. We added more bilingual texts of relevant Chinese regulatory files. The BLEU score increased. And when we took off the sentence dictionaries from a previous model, the BLEU score increased. As the result changes, we saw that using bilingual Chinese legal texts for training our engine can improve the BLEU score.
Here was the scoring method for our pilot human quality evaluation, which prioritized needs specific to legal texts, mistranslation, accuracy, terminology, consistency, and style. Our round 1 raw engine failed, and so did our round 1 even with post-editing. Our round 10 raw translation also just barely failed, but our round 2 with post-editing passed and showed major improvement. Interestingly, we also did a round of post-editing of Google Translate, which also passed. Here's a graph of the penalty points of our different translation methods. The red bar is our pass-fail line for our sample size. As you can see, Engine 10 with post-editing did quite well. And here's a time comparison of each translation type. Round 1 and round 10 post-editing actually took the same amount of time, but this is likely an issue due to our relatively small sample size. We can continue to improve the engine to be more efficient than Google Translate. For human translation, we used a benchmark of 300 words per hour. And now on to our updated proposal. When we expand beyond the pilot project, there are a few adjustments we have to our goals. We'll use the same measurements for quality, but the number of acceptable errors we can forgive will be lower. We'll also aim to make the engine usable raw without any post-editing. We don't want to create a 100% perfect engine, but something the client can use for internal use without post-editing. We'll also do fine-tuning to increase efficiency and thus decrease cost of use.
We recommend additional training for our NMT engine. A good first step would be to further clean our current dataset. Any additions to the dataset must directly pertain to cybersecurity. If low costs are the primary objective, this can be completed easily by pulling from the open source parallel corpus and creating strict filters that result in segments that only contain internet-related terminology. We estimate that the cost for just alignment alone to increase our dataset by 250% would be $6,461.54, at least if we continued at our current rate. This figure could be reduced significantly by only using files pulled from the open source parallel corpus, as previously mentioned. In this graphic, the blue lines are our original estimated timeline. The red lines on the bottom reflect our actual timeline. As you can see, we spent a significant amount of time compiling documents, nearly double what we had originally planned.
This is a comparison of estimated, actual, and predicted future costs. We stayed $483 under budget and stayed under our estimated hours required. We severely underestimated the time required to prepare and align documents for this project. We also did not account for other administrative snags, such as creating an Azure account. If we continue training the engine, the estimated future project cost will be $11,378.68. As quality is one of our key priorities while training an engine for legal texts, we are always looking for ways to ensure that minor slips can be eliminated as far as possible. Therefore, we can make sure the consistency and the accuracy of the source and target texts. Here are some settings we use when we post-edited machine translation and which we recommend other translators to use. In summary, Microsoft Custom Translator was reasonably effective and cost-efficient at training an engine to translate the Chinese cyber law texts through our improvement. We want to say that we definitely recommend to keep training the engine and use MT to translate the Chinese cyber law texts. Our pilot goals were met, but there is promising potential for improvement. Last but not least, each one of us would like to share with you our lessons learned when we were working on our pilot project. Thank you.
Thank you, Tonton. For lessons learned, I think what we can improve in this pilot project is the accuracy. A larger sample size of testing data and multiple post editors would help with quality evaluation.
One takeaway that I had was the importance of establishing naming conventions early on. Because we lacked a document explicitly detailing how files should be named, we had a lot of inconsistency with our file names and NMT model names.
Use what's already available. Hunt online for segments that are already aligned. Use open source parallel corpus for segments. Use a copiola font to cut down on your work. Using your resources will save you time.
To avoid garbage in, garbage out, we uploaded many files that we already aligned perfectly well, rather than let the machine automatically align for us. In this case, aligning data manually almost burned me out. Using different tools certainly helped. I learned some tricks to further break down the segments in Turtles so that we could have better tuning data. I also learned to generate TMX file in Turtles and use Elephant to check if the file format is clean and acceptable to put in our engine. So my lesson is that it is essential to know how to use different tools for data preparation in order to improve our work efficiency.
Yeah, thank you so much for watching.